To sketch this velocity function, let's examine it closely. Here the 20 indicates the baseline. It means that the whole sine is going to be moved up vertically by 20 points. And the 5 is going to indicate that the amplitude of that sine wave is going to go up by 5 and come down by 5. And the 10 indicates that there are going to be 10 cycles in 2 pi. So if we divide 2 pi by 10, that gives us pi over 5 for each cycle. And this will equate to 0.6283, so on. So we need to know that because we want to sketch this up to 2. So how many cycles can we get of 0.6283 into 2? And the next cycle will get us to 1.2566, then that's not enough. And the third cycle at 3 pi on 5 will get us to 1.8849, and we're nearly there. And if we want to find exactly, we could just put the time 2 in here. 2 times 10 is 20, and work out what the VT is. So VT would be 20 plus 5 sine 20, 10 times 2. And when we work that out on the calculator, we get a value of 24.56, which is almost heading up to that 25 over here. So we can more or less say that that is where our function stops over here at 2. So we really have about 1, 2, 3 and a bit cycles. And to find the cyclist velocity after 0.5 hours, all we need to do is just substitute that 0.5 hours into our original velocity function, and that will be 5 sine 0.5 times 10. Now working that out, we'll just get 15.2 kilometers per hour. To find the velocity after 75 minutes, we need to first of all change 75 minutes into hours, and that'll be approximately 1.25 hours. And now we do the same thing by just substituting 1.5 hours into our velocity equation. So we get 20 plus 5 sine 1.25 multiplied by 10, and we work that out to be 19.5 kilometers per hour. And to find the total distance traveled by the cyclist after 2 hours, it's quite interesting. Have a look at the graph and have a look that this graph has a sine function, and that at whatever time the horizontal is our time, at whatever time the velocity, whatever time we put inside our velocity function, we will always get a positive number. It'll be always positive. Even when we go here below what seems to be below the 20, whatever time we put in, it is always going to be a positive number. Positive, 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 positive. So what we're saying is that the velocity is always positive. If we were to draw the velocity diagram, then we could say from the very beginning to the very end of time 2, we always get a positive value, which means that the direction never changes. And if the direction never changes, all we need to do is find the displacement at the original position, and we also need to find the displacement at the final position. So to do that, we need to integrate our velocity function from 0 to 2. So let's do it again. This time we'll put the function in 20 plus 5 sine 10t. And we need to integrate that function. 20 becomes 20t. Sine is a minus, becomes a minus cos. So it's 5 cos 10t over 10. And we do it from 0 to 2. It's just 20t over 1/2 of cos 10t from 0 to 2. Now we can just substitute the 2. 20 times 2 is 40 minus 1/2 cos 10 times 2 is 20. And take it away from 0. So 0 times 20 is 0 minus 1/2 cos 0. Simplify it all together, minus 1/2 cos 20. Take away, 0 is nothing. Take away, that's 1/2 cos 0. And that continues to be worked out as 40 minus 0.2 plus 0.5, 40.3. And the units of it would be kilometers. And more videos of this kind coming up, so please subscribe.